Here's the stable gated 3-frequency PWM, and so what you see there on the screen, you got the lower frequency there, or the lower trace, is for the frequency that controls the other two frequencies, so it's the gating. I'm going to adjust the pulse width of that gating, and that's what it does. So pretty much you got, this controls the two other frequencies like I said, and they are inverted. So when one is on, the other one is off, and when one is off, the other one is on, so they are inverted. So that's controlling the pulse width. Now this is to control the frequency of the gating. So that's the effects that you get. Now I'm going to adjust the pulse width of the second frequency there, so wider and thinner. Now I'm going to adjust the frequency of that second. So one thing that I call it stable is because the pulse width pretty much remains in the same ratio. So right now it's almost 50-50. So as I change the frequency, the pulse width remains in the same ratio. That's why for the name I call it stable, because a lot of other circuits, when you change the pulse width, the frequency changes, or the other way around, when you change the frequency, the pulse width ratio changes. So I worked on this to make it where they stay the same, so it's easier to adjust. So now I'm going to adjust the pulse width of the last frequency. So you could even lock it where it's on all the time. There you go, that's about 90-something%. And very short. Now I'll leave it there, and I'm going to change the frequency of it. So the ratio stays around the same 50%. It does fluctuate about, I've checked it before, it goes from, let's say, 50% to 49%, 48%, so it does fluctuate about 2%, which is not too bad. And so here's the circuit. So you got frequency, pulse width, frequency, pulse width, frequency, pulse width. I have it set up with 600 volts MOSFETs, and has a voltage regulator, and that's about it.